Hello and welcome in, everyone. My name is Brian, here for Tuesday afternoon mathematics streams. Hope you're all doing well on this beautiful sunny Tuesday. Today I think is going to be a little bit of a short stream. Just wanted to finish up some of the questions that were posed inside of the Discord server for Olive. We had done, I think, good work on number 4. And as well, we solved number 3 and posed an extension question with Puzzle Andy last stream, which was yesterday. So I would like to finish up these 3 particular questions, taking a look at number 2, because number 2 is a little interesting as well. Or at least I found the results a little bit surprising. So let's call this Olive number 2. And we're going to think about the number of values of x inside the interval. The interval is really weird. It's a negative 11 pi to negative 2 pi. What is this? Can you prove the Hardy-Littlewood Sobolev inequality for me? Probably not. I don't even know what that is. Oh, man. I'm going to look it up now, though. Hopefully, it's actually a thing. Those sound like they're mathematicians. Might be some ads incoming for you guys as I look up. Perfect timing, right? Perfect timing. What does this even deal with? Ooh, kernels and convolutions. I've worked with those before, but... So a Hardy-Littlewood Sobolev. It's about LP space, yeah. I haven't worked in those in a long time. So if P is bigger than 1, is P a prime number? And alpha is some multiplication. Then I have no idea what this means. Nope, definitely will not be able to even talk about this. Because I never took real analysis. I skirted my way around it, so I didn't have to worry about it. The biggest pain I ever had to learn. Honestly, like real analysis, it's a little bit in like metric spaces and like dealing with all of that stuff. Like, no thanks. I mean, I understand the value of it, but I just never got into it. It was never my thing. Man, what is this? Man, 1 sec. So, Lebesgue integration. Yeah. I never got there. Surprisingly, I never took that as a part of my undergraduate. I took too much statistics and probability, apparently. Anything that would keep me away from real analysis. Now, when I started thinking about this particular problem, so we need this equation to be identically equal to 0. So we need we need 5 cos x plus 4 to equal 0, but not 5 sine x plus 3 to be equal to 0. Because if they're both equal to 0 at the same time for a particular value of x, we are in trouble. Then things are going to get a little funky. Don't you need tons of LP spaces in integration theory and statistics is probably why I didn't do very well in statistics. But yes, yes, you definitely do. When we started doing like, it was when we started doing like probability spaces and we had to like integrate over like multi-dimensional manifolds, I started to like lose interest. It got to be a little bit too complicated. Okay, so let's see. I mean, certainly it's true that cosine of x is going to be negative 4 over 5 somewhere on that interval, and it's certainly true that sine of x is going to be negative 3 over 5 somewhere on that interval, because these fractions are, what, bigger than negative 1, I guess? Yeah, that's when statistics got a little scary, when there was, like, vectors flying around everywhere and you had to do, like, work with vectors. I was just like, It was hard enough doing stats with, like, a single variable, let alone, like, n variables. So I wonder if we can figure out how many times this happens. Because it just says compute the number of. It doesn't ask us to actually find the explicit values. And maybe the same over here. I'm just going to color code them. So same question. Can we do this just by like figuring out what cosine and sine look like? So we're going to pick like negative, maybe I'll do this in black, like negative 11 pi to negative 2 pi. That's probably not gonna, we're gonna need a little bit more. Let's actually draw the curve first. So let's make sure I get this right and don't look like a fool. So cosine starts up here, right? So cosine's gonna do its thing. I can probably make this a little bit smaller though. I don't know how many of these I'm gonna need, but it repeats every 2 pi or something like that, right? So this should be negative 2 pi. Negative 4, negative 6, negative 8. So we're gonna need a lot of, probably don't need this whole diagram, but just to help my thinking, to start off helping my thinking. Let's just draw the full picture. So we're gonna need to go all the way up to, this is negative 10 pi, 10, and so this will be negative 11 pi right here then, right? Levi Roseman, hello. A long time no see. Hello, my brethren. I added a new tag just for you. I think, yeah, the tag is #MathGod. And the very first question of the stream, I couldn't solve. Therefore, I must have to remove this tag the next time I stream. How many times is cosine going to cross over negative 4/5? That's going to be somewhere down here, isn't it? So could we probably, like, could we realistically say this is probably going to happen 1, 2, 3, 4, 5, 6, 7, 8, 9 times? Does that seem reasonable? I think that seems reasonable. So cosine is going to be -4/5 9 times. For sine, shouldn't this be the same for sine? But sine, let's do sine in red. So sine is like this, right? So it's gonna fuck, I hate drawing sine and cosine at the same time. Okay. Oh, the struggle is real. I need to go back to pre-calculus. Okay, I think we're okay. Clearly not drawn to scale. Something like this. And we need sine to be -3/5, which is going to be a little bit higher than -4/5. Oops, let's keep the ruler there. And let's just mark out. Oh, okay, so that's going to be a tricky one. Is there one in there? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So maybe 10. 10 times? I suppose we could go like full on calculator with this. We could calculate some stuff in radians, I suppose, and actually get solutions. I didn't really want to do that, but we could do that. Ba-boom. And now it's time for Click SMR, your favorite time of the day. So we need inverse cosine of -4/5. And I'm in degrees right now, I don't particularly care. So we're gonna get 143.13 degrees. Okay. That's our reference angle. And if we solve, where's sine inverse? Sine inverse of -3/5. What's our reference angle here? Oh, -36.87. They don't look like they're going to overlap. But I suspect since this is a contest question, they're going to overlap somewhere. Big news later. Okay, I'm excited. I'm excited for the big news. I know you've made some, it sounds like you've made some changes. And you also sound really damn excited to talk about those changes. Which is cool. I think that's great. I guess I could... Oh, I wonder... Can I replace cosine with, like, sine? Can I just replace cosine with, like, a phase shift of sine? Is that a thing I can do? Because these degrees don't feel... I don't know. I feel like those reference angles aren't really helping me that much. How does this work? If I take cosine and I need to do it with sine, I think, right? If I take sine of x and I shift it to the left by 90 degrees, by pi over 2. So if I go x plus pi over 2, that's equal to cosine. Is that true? I think that's true. Right, and then these things would line up. Let's verify that. I feel like that's truthful. I don't think I need the questions anymore. You can tell I haven't taught pre-calculus in a very long time. The struggle is real. So let's take sine. Let's go x plus pi over 2. And let's look at cosine. Okay, so those overlap. We're good there. So that is a truthful identity. I could use this identity. That means I could take the first equation and I could replace it with sine of x plus pi by 2. That would be negative 4/5, and then we have the second equation too, of sine of x is equal to negative 3/5. Does that help at all? There's a weird thing about sine and cosine, isn't there? And it's a contest thing. I don't think it's what I need, though. I don't think that's what I need. Because there's something that says, like, if x and y add up to 90 degrees, then sine and cosine are... How does it work? I think it's like if x plus y equals 90 degrees, then sine of x equals cosine of y. I think there's some weird relationship like this, and they always use it in these contest questions somehow. So sine of x can be equivalent to cosine, but here it's the same thing, right? It's the same x. And so cosine and sine for the same x, that's usually a pi by 4 problem, isn't it? But it's almost like these are going to be, so weird. How do I do this? How do I solve these equations? I think that's the problem. The problem is you probably can't. So the other way is, how do we convince ourselves that there are probably some places where cosine of x is negative 4/5, and there are also some places where sine of x is equal to negative 3/5? And how many of those places exist? The top two are equivalent to these two. So is it possible to find x values where when we phase shift by pi over 2, we move from -3/5 to -4/5. Is 3, 4, 3, 4, 5? This feels like a triangle. Let's draw that triangle. Okay, if x is here, maybe I should draw this like in the xy plane. Okay, so where is sine negative? Sine is negative here and here. And if x is our reference angle, we need to get -3 over 5. And when we square 3, and so that means this is going to be a distance of 4, right? So, oh no, one of these is -4. Oh. Oh, okay. Oh, okay. Yeah. Oh, that's a good idea. We could have used we could have used the double identity angle for sine if we wanted to expand this one out, I suppose, right? And then we can make some substitutions and maybe solve it that way. That's an interesting idea. I didn't think about that. But I think I just answered my question right here. Yeah, so I think I've convinced myself here that half of the possible solutions need to get removed because this triangle in particular is going to be a bad one, right? And this one here. Because exactly that reference angle x has sine of -3/5 and cosine of -4/5 at the same time. Is it possible to do it algebraically? I seem to be on a little bit of a roll over here, so... Okay, so let's get rid of that. That wasn't super helpful. Or no, wait, I wanted to look at that. Okay, so this is a sine double angle is 2 sine wait. That's not a double angle. This is just sine of a plus b. What is sine of a plus b? It's that one, right? So if I did want to, I think so. Puzzle Andy, hello, how are you doing? Busy today, but leave a lurk. Thank you for the lurk, much appreciated. Enjoy the trig, homies, yeah. I am not enjoying the trig, because you always have to know so many identities. So this should turn into what? Sine of x cosine of pi by 2 plus cosine of x sine of pi by 2. Is that what you're doing? So you multiplied them together. Oh, and then did a double angle. This is a sine 2t. So t is half arcsine. So it's possible, that's interesting. So it's possible to actually get specific solutions in the form of the reference angle. Okay. And then you just have to make sure to repeat that every pi? No, every 2 pi. Yeah. I don't think my way is going to go anywhere pleasant. It just looks like a lot of algebra and not a lot of convincing. I feel like this is a good enough argument. I know that the ones that come after, so this is going to be a rotation of pi. So the one that comes on the rotation of pi to 2 pi is going to be the problem. But that's going in a positive direction, and we are going in a negative direction. So the one that's going from 0 to the odd, right, so it's going to be our negative pi, is going to be the issue. The one that's closest to the odd ones will be the problem. Because I can kind of think about this as like the same as 0, right? So it's not going to be the first one that we hit. It's going to be the second one that we hit. That's going to be an issue, and I'm looking specifically at, let's see. So chances are, that sucks. Chances are these two are actually the same, and I think the same is going to happen over here. So it's not the first one that we hit, but it's going to be like the second one, I think. So there's going to be a couple of overlapping solutions. My drawing over here is really bad, but I think it's like something like this. And then when I hit 10 pi, which is like 0, I am going to hit one more in here on my way over to 11 pi, right? So there's going to be 1, 2, 3, 4 good solutions to this problem. 4 good solutions. And 5 not so good solutions. Okay, let's see. Let's look at the function. Ba-boom over ba-boom. And numerator is 5 cosine plus 4. And this was 5 sine plus 3. 5 sine plus 3. And let's restrict this. Let's go negative 11 pi up to negative 2 pi. So we have 1, 2, 3, and 4 possible good solutions to this equation, which is what I think we have, right? 1, 2, 3, 4. So there are 4 values on the interval that will satisfy this is equal to 0. What an interesting question. I wasn't expecting to have to warm up so boldly to trigonometry, but here we go. All right, so hopefully that helps you out, Olive. Hopefully that gives you at least a little bit of indication on how we can do that. And then, yeah, if you're watching the video on demand, Levi threw out an alternate way to think about that into the chat. So take a look at that. More of an algebraic argument by the looks of it. Okay, you know what time it is. It's been a while. It's been a hot minute. It's been a long time since we've started looking at Euclid contests. Let's get back to it. I'm going to do a couple questions from the Euclid contest. It'll be a little bit of a shorter stream today. We'll probably try to end around 4. But I think we can probably power through at least a couple of these preliminary questions. They tend to be relatively straightforward. Although every once in a while we do get bested on these, on these questions, don't we? So this is the 2018 Euclid contest. 2018 Euclid contest. Let's look at number 1. And as always for you viewing, if you do have some questions, do feel free to post them up into the chat, and we can get around to working on your mathematics questions as well. So, are there easy ways to do this? So this is just like 11 plus 12 plus 13 plus 14. But there's probably an easier way to do this. I bet if we collected the x's together and we collected all the numbers together, it'd be easier to add. 3, 4, 5, 6, right? So if we did 4x plus 6, this would be 4 times 11 plus 6, which is a little bit easier to do mentally, I think, right? 44 and 6 should give us 50. Rather than doing 11 plus 12 plus 13 plus 14. I think that would be harder. So if a over 6 plus 6 over 18 is 1, what is the value of a? Why don't we take that left-hand side? We know that these two fractions have to add up to 1, so why don't we just give them the same denominator and try to figure it out from there? So if I give this first fraction the same denominator, or can I, I could actually probably keep the first one and reduce the second one down to a denominator of 6 by dividing by 3. Right, 18 by 3 is 6, and 6 by 3 is 2. And if both of these have to add up to give me 1, doesn't that mean that a is equal to 4? I feel good about that. All right, here's probably the trickiest one. Yeah, 3 over 18 plus 6 over 18 equals 1, if and only if a is 4. Turn a mental math question into a proofs question. Go. Oh, I hate these questions. Okay, the total cost of 1 chocolate bar and 2 identical packs of gum is $4.15. 1 chocolate bar, it costs $1 more than a pack of gum. Determine the cost of a chocolate bar. Can we just do this with like linear equations? So 1 chocolate bar plus 2 packs of gum is $4.15. But a chocolate bar costs $1 more than a pack of gum. Yeah, so we should be able to just do substitution, right? We can sub this up in here.
Time for a pop quiz.
Might be some ads incoming. So g plus 1 plus 2 more g, so that gives 3g's plus 1 is equal to 415. So 3g is 315. Oh, and that does divide nicely by 3. So a pack of gum is $1.05. Now, if a chocolate bar costs $1 more than a pack of gum, I suppose the chocolate bar probably costs $2.05. Let's see, how are the warm-up questions? How do we do? I picked the wrong thing. There we go. All right, 50. A is 4. And $2.05. Nice. We are off to a rockin' start. Now, these are light bulb questions. Usually that means we can do a lot of this work mentally with regards to the Euclid math contest. So let's see if we can answer 2A and B kind of in one go, and then we'll keep the pen and paper one. This is number 2A and B. Is that actually a quote from Bertrand Russell? That would be hilarious. We now prove the occasionally useful result that 1 plus 1 is equal to 2. If he actually stated that out loud, that would be legitimately hilarious. No way. What a Chad. What a Chad. After 100 or so pages of set theory, he decides that 1 plus 1 is equal to 2. That's great. But I mean, Russell was playing around with infinity and stuff like that, wasn't he? But yeah, to swoop in and like actually make mathematics into mathematics, that's a big Chad moment. Okay, a 5-digit integer is made using each of the digits 1, 3, 5, 7, and 9. The integer is greater than 80,000, but less than 92,000. The units digit is 3. The hundreds and tens digit in that order form a 2-digit integer divisible by 5. What is the 5-digit integer? I assume we have to make the integer using one of each of these. So the units digit is 3. And we know that the hundreds and tens digit form a 2-digit number divisible by 5. So I think 5 is the only choice here. So now we have left 1, 7, and 9. Well, we do know that the integer has to be bigger than 80,000, less than 92,000. So I suppose 7 has to go here, right? 1, 3, 5, 7, 9. Oh no, I'm dumb. I can't put 8, 7 there, can I? It's got to be 9. Which is going to force our second digit to be 1 and our last digit here, or 100's digit, to be 7. That should do the trick. I'm just tossing a 7 down. Yeah, legitimately, this guy just publishes a paper just proving that 1 plus 1 is equal to 2 and just doing like every possible addition. Just proves every possible addition. That'd be hilarious. The best part is, like, somebody actually would probably read that paper. Oh, have you seen Corollary 3572 from Bertrand's paper, Principia Mathematica? Oh man, that was thrilling. I didn't think he could pull that one off. Okay, 2b, in the diagram, point D is on AC, so that BD is perpendicular to AC. Okay, we have that there. It's shown to us with the little tiny square. Also, AB is 13, BC is 12 root 2, and BD is 12. Okay, what is the length? What is the length of AC? Now, we could probably say that AC is equal to AD plus DC These are nice Pythagorean triples, aren't they? What goes in there? 5? So AD is going to be the square root of 13 squared minus 12 squared. What is that Pythagorean triple? Is it 5, 12, 13? I know I've seen that Pythagorean triple somewhere. And DC should be 12 root 2. This is where things are going to get a bit murky. So we get this one minus 12 squared. I think it's 5. 169 minus 144. That's 25. Okay, so this is going to be 5. What about this one? This one is 144 times 2 minus 144. So 2 copies of 144 minus 1 copy of 144. That's 1 copy of 144, so that's 12. Is AC 17 units? No, wait. How is DC also equal to 12? Oh, because it's a 1, 1, root 2 triangle. Okay, yeah, that makes sense. 1, 1, root 2. 12, 12, 12, root 2. Got it. All right, let's finish up question number 2. Okay, what do we got going on here? We have a square OABC. OABC has side length 6. Okay, that might be important. The line with equation y equals 2x, so that's this line up here, intersects CB at point D. Determine the area of the shaded region. Okay, we can probably do this. Should we do the full region minus the white region? So full. So the shaded region, we could say that it's the full square minus the white triangle. And we know the size of the full square should be 6 by 6, right? Or 36. So if we could find the area of the white triangle, we'd be in business. That is a right-angled triangle. We could probably find intersection point D, couldn't we? So D happens to be the intersection point of y equals 2x and y is equal to 6, right? Because this distance from here to here is 6 units. So if y is equal to 6, we know that 6 is equal to 2x, so x should be equal to 3 here. So this point is 3, 6. It feels weird. It looks like they purposefully didn't put it at like the midpoint of BC just to make it look funny. But, I mean, that must be the midpoint of BC. So if that's, well, all we really need is base times height over 2. So the base is 3. The height is 6, and we divide that by 2. So that will be 3 times 3, which is 9. So 36, is that divisible by 9? 20, so 27? 27 units. Let's have a peek. Okay, number 2. The 5-digit integer 91753. Excellent. AC is equal to 17. Perfect. And solution number C, finding the area of the shaded region, must be 27. Nice. I think I got a few more in me. Let's try 3A and B. Nice warm-up questions to get me ready for the hell that's going to be coming through by the time we get to like Thursday or Friday's stream. What is this? This is 2018. This is our Euclid contest number 3, A and B. Oh, goodness. Okay, what is the value of... That's a lot of 4s. So 4 plus... So this 4 just means 4 copies, right? So we're going to get... We could do 2 copies here. And 2 copies here. That should be equal to the starting thing. And squaring is going to give us 4 plus root 4 here, and 4 plus root 4 here. So let's expand that out. 4 by 4 is 16, and then we're going to get 4 root 4s plus another 4 root 4s, and then we'll get root 4 squared. Okay, so that should give us 20 plus 8 root 4s. Yeah, the square root of 4 is just 2, though. Why am I an idiot? Bah. That was obviously the long way, because if you realize that if you realize that you could just simplify this 4 here, you'd just get 4 plus 2, so you'd get root 6 to the 4. So that's going to give you 6 times 6, which is 36. Much faster. Okay, last question of the day, guys. And then I have to deal with some dog things. And then head for a beer. Because that's what I want to do this afternoon. There is exactly one pair xy of positive integers for which this equation is true. What is the pair x and y? I don't really want to square everything. There's exactly one pair. What does, like, exactly one pair of positive integers? Is this obvious? So 8 minus some square number has to be equal. I wonder if this is just like a guess and check kind of game. Because we can't really go too far, right? We only have a couple choices for y. Y could be 1, in which case 8 minus 1 is 7. Y could be 2. And that's it. Y could be 2, so 8 minus 4 is 4. So there are very few choices here. Very few choices. We can adjust the doggo cam slightly because Shay's sitting on the far side of the couch. I can have a little look at Shay having a little nap. And I guess I should probably do the same thing for the x's, right? So let's see. 23 minus x is going to have a very few... Well, I guess it's going to have more than I think. But what I really want is I really want to force this to be a perfect square. So x and y have to be positive integers. So the best I can get is that this is equal to root 16. Which would give me 4. I could get root 9, which would give me 3. And then root 4, which would give me 2. And root 1, which would give me 1. So there's only one of these things that's common on both lists. So we need to turn 23 minus x into 16. So what is that? X should be 23 minus 16. So what is that? 6, 7? If x is 7, that would work. So I believe the only xy solution that is going to work for positive integers is going to be 7, 2. I don't know how you would do that in a faster way than just kind of guessing and checking, though. Let's see if there's some insight before we peace out for the day. Couple skip. So 3a, 36, 3b. So 8 minus y squared is an integer, therefore 23 minus x is an integer, which means that 23 minus x is a perfect square. Okay, so that's exactly what I thought. Okay, and then they just made a table as well. Okay. And then they found the one that works. Cool. Alrighty. Well, I think that's going to be stream for today, guys. I will hopefully be back Thursday. I think I'll probably do an early stream on Thursday because I do have a meeting at 4:30. So we'll try for an earlier stream on Thursday if I can do that, and if not, we'll push it back probably to the weekend. But that'll be tricky too because of my work schedule. But we do have a big event, so if you're in the Kelowna region, big event, Railside Brewing, come hang out Friday afternoon. It's going to be a beer garden. I'm going to be working. So if you're in the neighborhood, come say hello. But until then, guys, until then, hope you all have a fantastic rest of your afternoon. And I will see you hopefully on Thursday, and if not, a little bit later in the week. All right, so take care, guys. Stay positive wherever you're dialing in from. Good to see all of you. Good to see you, Levi. Good to see you. Puzzle Andy, thanks for the lurk, and we'll catch up soon. All right, guys? Cheers.